In this video, we're going to look at ordering integers using number lines, and we're also going to learn about inequality notation. So let's start by looking at some of these facts, notations, definitions. Okay. So this is a fact that you're probably very familiar with, even though you probably don't think of it much. If two numbers are not equal, one must be less than the other. One number is less than another if it falls to the left of the other on the number line. So we're going to be determining ordering which of two numbers is bigger or smaller, less than or greater than, by looking at a number line. And notice we have equivalently, if two numbers are not equal, one must be greater than the other. And one number is greater than another if it falls to the right of the other on the number line. So something to notice, we're starting to use less than and greater than here as opposed to smaller and larger. And this may make sense to you now that you've seen absolute value. So the positive number 1 is bigger than the negative number 1/2. But we may think of 1/2 as being smaller than 1 because its magnitude or its absolute value is smaller. 1/2 is smaller than 1. But negative 1/2 is definitely less than 1 because it's negative. So to make up for this, we really focus on using less than and greater than, which have these more clear-cut definitions in mathematics where we relate it to where the two numbers fall on the number line. So here's our inequality notation. So this reads 2 is less than 5. So this symbol right here, we read it as is less than, or the less than symbol. This inequality reads 6 is greater than 3. So this symbol is read as greater than. Okay? So this is how we read them if we're reading them left to right. Okay? So, but one thing you want to think of is the equivalency noted above. Because we said that if two numbers are not equal, one must be less than or greater than the number, we can actually read these in the opposite direction. And this is going to be really useful later when your inequality symbol may be in a way that's not as easy to read from left to right for some reason. So here, this we said is 2 is less than 5, but we can also read this as 5 is greater than 2. Okay? So you could write it as 5 is greater than 2. Okay? But sometimes we just say 5 is greater than 2 reading this. And one way to think about it is the open part of the inequality sign is always pointing towards the larger number. So since 5 is bigger than 2 here, it's pointing this way. And if I write 5 on the left and 2 on the right, it's pointing this way. Similarly, with 6 is greater than 3, we could also say 3 is less than 6. So we could write this, or we could just say this when we read this, noticing that the bigger part of the inequality symbol, it's pointing towards the 6, so that must mean 3 is less than 6. So learning to use these interchangeably will really help you to get a better understanding of inequalities. So let's look at some examples. Plot the given numbers on the number line. Determine which number is greater and insert the correct inequality symbol. So we're going to plot 6 and 3. So here's 6 and here's 3, and I plotted them directly on the line. Then it asks me, write the number that is further to the right. So further to the right is the number 6. Okay? And remember, by our definitions, since 6 is further to the right, it is greater than 3. So here it says insert the correct inequality symbol. So 6 is greater than 3. But we could also equivalently say that 3, since it's to the left of 6, 3 is less than 6. Let's look at the next one. Plot negative 5 and 3 on the number line below. Well, here's negative 5, and here's 3. The number that is further to the right is the larger number. So 3 is the larger number. So here, I'm going to point the inequality symbol so the open part is towards the 3, and I'm going to do the same thing here. Okay? So this reads negative 5 is less than 3. It's to the left of 3 on the number line. And this reads 3 is greater than negative 5 because 3 is to the right of negative 5 on the number line. Okay? So these are equivalent statements written in a different way. And finally, plot negative 4 and negative 7 on the number line below. So here's negative 4 and here's negative 7. The number further to the right is negative 4. So that means negative 4 is greater than negative 7. And here I'm also going to point the inequality symbol, so the open part is towards negative 4. And we could read this as negative 7 is less than negative 4. Equivalent statements. Okay? So notice here, the magnitude, or the absolute value of negative 7 is larger than negative 4, because negative 7 is 7 away from 0, and negative 4 is 4 away from 0. So typically we think of numbers with larger magnitude as being, again, larger, but remember now we're talking about less than or greater than, and negative 7, this could be like owing $7. Well, that would be having less money than owing $4. So you have to begin to look at these in terms, or visualize these in terms of the number line, and not just focus on the magnitude of the number. So now we're going to make a few generalizations. So if two numbers are positive, the one that is blank from 0 is greater. So let's just do this on the number line. I'm just going to make two positive numbers. This is like our first example. And the larger one is 7 because it's further to the right. So the one that is further from 0 is greater. And this will be true in general. If the numbers are both positive, the further it is from 0 compared to the other number, the greater it is. If two numbers are negative, the one that is blank to 0 is greater. So we have this situation here. Two numbers are negative. The one that we saw that negative 4 is greater because it's further to the right. And notice it's closer to 0. So the further you are in the negative direction makes you less than the other number. So if two numbers are negative, the one that is closer to 0 is greater. And here's one more generalization we can make. If one number is positive and one number is negative, the blank number is greater. So let's just look at these ones. Here's negative 4. Here's positive 5. Well, a positive number will always be to the right of a negative number because it's to the right of 0. So that means the positive number is always greater than the negative number.